Hey class, this is the 6th video in our stoichiometry series, and in this video we're going to learn how to go from moles of some substance, namely a gas, to liters of that gas. Now, we have to have moles. We can't go from grams to liters. It has to be moles. Luckily in this question, it gives us moles, so it's not a problem. The question says, how many liters of CO2 gas are produced if 2.5 moles of C3H8 tricarbon octahydride were consumed in this reaction? Now it gives us the reaction below, and it's already balanced, so make sure it's balanced first. This case, it's already balanced. C3H8 plus 5O2 yields 3 CO2 plus 4 H2O. Now, two key words: produced and consumed. Produced, that's obvious, that's a product. So how many liters of CO2 in the products were formed if 2.5 moles of C3H8 were consumed? So, consumed in this case is meaning used as a reactant. And obviously that's the only two places you find these compounds. Now, in order to get liters of CO2, we must first know moles of CO2. And to get that, we use our mole-to-mole conversion that we learned earlier. So first off, what is our mole-to-mole ratio of C3H8 to CO2? In this case, it's 1 to 3. So 1 mole of C3H8 for every 3 moles of CO2. Set that equal to what we want and what we have. Now, it gives us 2.5 moles of C3H8. And we're going to put that on top to match this side. So 2.5 moles of C3H8 is question mark moles of CO2. Now, moles is not what we're looking for, but we have to get moles first. So take our trusty phone calculator out, and we're going to cross multiply 2.5 times 3, and that's going to give us 7.5, and then we're going to divide that by 1, which I can do in my head. That gives us 7.5 moles of CO2. That's not the end, though. Again, we want liters. Now, for this equation, or this type of problem, there's one standard conversion, and it's 1 mole of any gas, we'll put gas right here, is equal to 22.4 liters of that gas. Regardless of what substance it is, it has to be a gas. 1 mole of that is equal to 22.4 liters. Now we're going to go back to our railroad technique like we have multiple times. We're going to take our 7.5 moles, so 7.5 moles of CO2, railroad track, railroad tie, over 1, again, because that 1's a place marker, it doesn't matter. Now, we want liters, so we need moles on bottom. And the simple way of writing this is 1 mole over 22.4 liters. Now, we want liters, we want moles to be on bottom to cancel, so we're going to flip that. So we're going to put 22.4 liters, in this case of CO2, per 1 mole of CO2. And now we're back to where we started from at the beginning. Cancel our moles. The bottom is a 1, we can just disregard that. And then you multiply straight across. 7.5 times 22.4. And that gives us 168 liters of CO2 gas. Now, it's as simple as that. We're just using what we already know, mole to mole conversions, and then our steps for grams to mole or moles to gram. But in this case, instead of grams, we have liters. And we're always going to use that formula. 1 mole equals 22.4 liters. In the next video, we're going to look at something very similar, but instead of going from moles to liters, we're going to go from moles to atoms or molecules. Same difference.